brainchild of mine. The Synod had put out last fall for some pastors, and Steve was there too, who I'll introduce in just a little bit, to be able to go out to lead, to talk about dark matter and about neutrons and do all the physics things that I'm not a physics major. It was amazing, and then we got to go underground at the Surf Center. And so I thought, and then a bunch of us pastors sat around and talked about what it means to be, what the science and this awesomeness that we get to learn about and the things happening in those fields, and then also what does that have to do with faith and religion, and how do they intersect, and what does it mean for us? And so we're going to kind of dive into that a little bit tonight. To dive into that takes forever. We'll try the best we can, but I'm glad that you're all here, and I just wanted to welcome you into this space as we get to dive into that. Couple of notes, just for a couple of things to note. In the building, if you have to go to the bathroom, if you go out down the hallways, either that way are the bathrooms. So if you have to do that, just to know where those are at. Also, Deb, when she does her presentation, will ask questions as she goes. She's a high school teacher, was a high school teacher, former high school teacher, and so questions she loves. But we're recording this also, so if you have questions, if you would wait for a microphone to come to you for a couple different reasons. One is so that way the question gets picked up online, and the other one is that way the people up front can hear what you're saying, because it's really hard to hear when you're in back and you're trying to yell your questions. So Pastor Chris and I will be in back, and we'll have a couple different mics for you to use to ask your questions. So Deb, Deb Wolf has been at the Surf. She was at Roosevelt. Some of you might know her. She was a high school teacher, administrative type person at Roosevelt for quite a while, and then she went out to Surf. How many years were you out at Surf? 8 years out at Surf in the Black Hills, and now she's working on retiring. But she has been gracious to go along with my crazy idea of being able to have this conversation with all of you in this place. And so I'm going to invite Deb up to go over her presentation and show you what she has. If you'd welcome her.
Hi. How's everybody doing this evening? Wonderful. Well, my name is Deb Wolf, and I am currently the Director of Strategic Partnerships at the Sanford Underground Research Facility. As Sarah said, I am a former high school chemistry teacher, and so this is my favorite thing to do, to be in conversation with people and to see when and experience curiosity with you together. So I'm going to talk about a bunch of stuff, and I know that I talk fast and the lights are a little bit bright, but please stop me. Like, you'll get like extra gold stars and all the things. If you have a question along the way, you wave at me, and we're going to pause and we're going to take those questions. Of course, if there are questions at the end, we'll have time for those as well. But I'm more than happy to take them as we go. I want to thank Sarah for thinking about this and coming up with this process. And Pastor Sarah was one of this wonderful group of pastors that joined us at Surf. And it was a different group of people to come to a science facility and experience what we do at Surf and to be in conversations. And it pushed me a lot and made me think differently about the work that we do. And I'm also really grateful for the American Association for the Advancement of Science, because they were the ones that actually funded the opportunity. They recognize that there are lots of different communities that should be in conversation about science and forwarding the work that is done in science. So very much appreciated for that. And you know, I was thinking about this the other day, and you might not really expect a deep underground science facility research lab and a church to have a lot in common. But it feels to me like both of those places are places where people come together to be curious, to ask big questions, and to wrestle with mystery. And I realize that I've already forgotten to advance my slides, so we're going to advance past the slide of me. It is on. And I'll shut it off, and then I'll turn it back on, and then I'll advance the slide. Oh, then they went away entirely. Yep. It's all good. Oh. All right, here we go. So before we talk about science and experiments and underground labs, I thought I'd start someplace just a little bit more personal with the idea, okay, so now it's going all on its own. But I want to go back. Because I want to go back. Here, we're going back. It's like we're going back in time, except it doesn't want to go back. Can you take me back to the slide with the Northern Lights? There we go. All right. I promise I didn't push any buttons. Are we sure? So these two experiences happened within a few days of each other. So one night, special night, many of you I'm sure experienced a similar thing. I just walked out on my back deck, I looked up, and there they were. I mean, that's a picture from my back deck of the Northern Lights. And then the other picture is something very different, but at the same time, I got the same feeling. That picture is a picture of a cavern. It's one of three, actually, that is a mile underground at the Sanford Underground Research Facility. And that's been recently excavated as the beginning for the largest experiment ever attempted on US soil. The caverns are enormous, like literally cathedral size, and completely unexpected when you're a mile underground, right? What struck me in those two moments is that they both gave me kind of that same feeling, a kind of quiet, a sense of scale, and the feeling that the world is bigger and stranger and more mysterious and more beautiful than you think about sort of in your day-to-day average experiences. And that feeling, that sense of awe, I think is oftentimes where both science and faith begin or are renewed. So when people hear that I work at an underground lab, they think that the kinds of questions that we wrestle with are highly technical and abstract, and they absolutely can be. But at their core, they're questions like these, which are not just scientific questions. They're human questions. And they're questions that people of faith have been asking for centuries. And scientists ask them with experiments and data and math, different approaches for sure, but oftentimes with the same curiosity underneath. From where I stand, they're looking at the same universe with just different lenses and different practices. What I'd like to do tonight, I guess, is to talk about some of the questions that we pursue at SURF, about why we go underground to do it, what we've learned so far, and also what questions we're still really wrestling with. Not to settle these questions or have actual answers, but rather to invite wonder and curiosity and conversation. But before we go underground or out into the universe, let's go to LEED. So the Sanford Underground Research Facility is located in Leeds, South Dakota, in the former Homestake gold mine. That gold mine operated for 125 years and was one of the most prolific gold mines in the world. During that time, miners would work on the surface, and they would work deep underground, drilling and blasting and hauling rock, and creating a really complex, robust underground footprint and infrastructure that allowed them to excavate as deep as 8,000 feet below the surface. And in the 1960s, while Homestake was operating, a physicist by the name of Ray Davis installed an experiment at what's called the 4850 level, so 4,850 feet below the surface. He installed an experiment called the solar neutrino experiment. And he was trying to detect neutrinos. And neutrinos are nearly massless particles produced in enormous numbers in our sun. And his experiment literally helped confirm how our sun produces energy. And it also really launched an entirely new field of research. And for the work that Ray Davis did for 30 years at the Homestake mine, he was awarded the Nobel Prize in Physics in 2002. How many of you knew that there was a physics Nobel Prize won in South Dakota? Well, now you do. Now you do. Go tell your friends. So today, the Sanford Underground Research Facility builds on the history created by Homestake. Much of the science that happens at the lab happens at the 4850 level, so 4,850 feet below the surface. The laboratory space for the experiment that you see in that fourth picture, that is Lux Zeppelin, our dark matter experiment. And Lux Zeppelin occupies the same space that Ray Davis's solar neutrino experiment housed for 30 years underground. You know, what makes science possible at SURF is the footprint that was created by 125 years of mining. We're leveraging the existing shafts and tunnels, we call them drifts, the ventilation pathways, the water mitigation system, wastewater treatment plant, all of that stuff that was needed to actually move rock 8,000 feet below the surface during mining days. Much of the expertise that was needed to do that work is needed today. It just has a different purpose today. All right, so what does that underground footprint look like? So let's orient ourselves. How many of you have been to Leeds, South Dakota? Nice, so you know the open cut. The really, really big, giant open cut. I want you to look up at the surface up there. Look off to the left, go along a little ways, and see the little dip? Beep. That, my friends, is the open cut. So, and this is close to scale. So what you are seeing underground is 370 miles worth of drifts and shafts, tunnels, about 12 of which we maintain yet today. All right, let's go back up to the surface. See the two little white buildings at the surface? If you've been to Lead, you've probably seen those. They kind of look like a grain elevator. Those are what are called head frames. And there's the Yates head frame and there's the Ross head frame. And directly beneath each of those are 5,000-foot shafts. And that is how we move people and stuff underground. You'll also notice the yellow, and there are two exits in yellow. Those are actually, on the surface, giant fans that are pulling air from the underground. That's creating the ventilation. The green horizontal line that's about 2/3 of the way down, that is the 4850 level. That's 4,850 feet below the surface. That's where most of the science is happening. At its deepest, Homestake was mining at 8,000 feet, so that's the lowest level. And I will mention that from 8,000 feet below the surface up to the 5,500, so a little ways below the green horizontal line, that is all underwater. So water infiltrates every single day, and it's flooded from about 5,500 on down. I'm gonna pause. Oh, I don't see any hands. All right, I'll go to the next slide if nobody wants to ask a question. All right, so at this point, I think it's worth zooming out for a moment and to provide a little additional context. So around the world, there are 16-ish underground labs. There is only one of significance in the United States. That is SURF, the Sanford Underground Research Facility in Lead here in South Dakota. And most of the rest of the underground labs are in operating mines, so active operating mines. SURF is one of very few that is fully dedicated to science. SURF is part of a global scientific effort, an underground scientific effort, that is both collaborative and competitive. So yes, researchers collaborate together, and yes, they want to be the first to do whatever it is that they're doing. So whether it's the study of neutrinos or discovery of dark matter. But it's a relatively small number of places around the world where underground science is happening. And that feels like it begs the question, why go underground? Like, what is it that you can do underground that you can't do on the surface, or that you have to be underground? And the answer is, what you're looking at up there is not rain, it's not snow, it's not any form of precipitation. On the surface of the Earth, we're constantly bombarded by particles from space. These are cosmic rays, high energy particles created by exploding stars and distant galaxies, and they strike the Earth's atmosphere every second of every day, all the time, constantly bombarded. Most of the time, they go completely unnoticed by us. Anybody feeling the cosmic rays pounding on you right now? You know, not so much. However, the detectors that we build at SURF to study things like dark matter and neutrinos are extraordinarily sensitive. They're designed to notice these incredibly rare events. Sometimes only maybe a handful of these events will occur in an entire year. If we tried to operate our dark matter detector or our neutrino detectors on the surface, they would be completely overwhelmed by the cosmic rays. Every single one of those cosmic rays that interacted with the detector would appear to be one of those rare events. And so all of our researchers would be doing, oh, well, that's not it. Oh, well, that's not it. Oh, well, that's not it. And so those rare, important events would be hidden. I think there's kind of maybe an easy way to think about this. And that is, if you want to hear a whisper, you step away from the noise. And so if we want to hear or see or experience these rare events, we step away from all of the background. And so we go a mile underground. And what does that do? Well, stay along with me for a second. Everybody hold your hand out. Pew, pew, pew. Like that's about the frequency that a cosmic ray would be striking your hand, or is, I should say. You're just not noticing it. All right. So then you get on the cage, which is the ride that you take to get to the 4850 level. So you get on the cage, you ride for about 12 minutes, and then you get to the 4850 level, and then you hold your hand out. For a couple months, because it's about 10 million times quieter a mile underground, 10 million times fewer of those cosmic rays. And so therefore, we can put our detectors underground, and then these rare events, if they happen, if we detect them, can stand out, they can fluoresce. The researchers can see them. Going underground, however, doesn't make the science easier. It just actually makes it possible, right? It just makes it possible. But I assure you it's not easy. So once you've gone to the trouble of creating your detectors, moving them a mile underground, what is it that we're looking for? What is it that we want to see or hear or know or understand? Come on, slide. I know you can do it. But if I advance it and then it's already advanced, then it's going to advance twice. All right. So one of the biggest surprises in modern science is that when we look at the universe, at galaxies, at clusters of galaxies, at like the big universe, it doesn't behave the way the physics that we understand think it should. All right, so I want you to imagine for a moment you're on a merry-go-round, okay? Merry-go-round, and you're out on the edge of the merry-go-round, and it starts spinning, okay? And you're holding on. Now, if it spins faster, what do you have to do if you want to stay on? Yeah, you have to hold on tighter, right? The faster it goes, the more it feels like you're going to fly off. My brother was really good at getting it going really fast and trying to get me to hold on. And the same thing happens with galaxies. The faster something is moving, so as the galaxies are spinning, and especially those that are out on the edges, the faster they're spinning, the more gravity they need to hold on so that they don't fly off. And when astronomers do the math, they add up all of the mass, all of the matter that they can see, planets, dust, stars, etc. There's not enough matter. There's not enough gravity. There's not enough matter to hold those stars. They should be flying off. They should be flying apart. But they don't. And the simplest explanation is that there must be more matter. It's just matter we can't detect. It doesn't give off light, it doesn't absorb light, we can't see it with our telescopes, and so we call it dark matter. It's not like it's bad matter, it's not that it's black, it's just unknown. So, if dark matter doesn't absorb light and it doesn't emit light and we can't see it with our telescopes, how are we going to detect it? I mean, we're pretty sure it's out there. How are we going to detect it? Well, at SURF, we have an experiment, the Lux Zeppelin, or LZ for short. LZ is currently the world's most sensitive dark matter detector. And it's designed to look for interactions that would happen between a dark matter particle and an atom of xenon. Xenon's an element on the periodic table. LZ, Lux Zeppelin, is filled with 10 tons of liquid xenon. And very, very occasionally, very rarely, the science suggests, our best understanding today suggests, that a dark matter particle should collide with one of those xenon particles, give off a flash of light, and give off an electrical symbol, and that should be the interaction. That should be what we're looking for. And it may only happen once or twice a year that interaction actually happens. Or, if our current model of what dark matter isn't correct, not at all. So scientists oftentimes say that looking for dark matter is like looking for a needle in a haystack. But actually, what LZ is trying to do is shrink the haystack. Each time we collect data and we don't see dark matter in the region that we're looking for, we exclude that region. We say, these are not the properties, these are not the characteristics of dark matter. In other words, not finding something doesn't mean we failed. It means we've learned something. We've learned what it is not. And that kind of science actually requires an amazing amount of humility. Our researchers build the experiments, they wait patiently, they analyze a ton of data, and they accept whatever answer they are given, including the answer, not here, not this, not yet. Either way, we're learning things. So there's another experiment, and it's another physics experiment, and in many ways it really defines why the Sanford Underground Research Facility exists. The image you're looking at is one of those 3 enormous caverns I referenced at the beginning. It is a cavern that right now they are constructing for the Deep Underground Neutrino Experiment, or DUNE. Look at that image carefully. If you look carefully, you might be able to see a 7 or 8 story staircase in the back, or you see the very, very small person in the front. That scale seems surprising, that you would have a cavern many stories tall and football fields in length. But the kind of questions that they're asking require detectors of that scale. So DUNE is designed to study neutrinos, particles that are produced in enormous numbers. In fact, here's a number for you. Trillions of them are passing through you and me and everything every second. And they're passing through all matter and us, all matter, completely undetected. And the neutrinos, our physicist friends really believe hold the key to understanding origins of the universe and why we are all here. The neutrinos that our experiment will use will be created at Fermilab. Fermilab is located just outside of Chicago in Batavia, Illinois. And when this experiment starts, those neutrinos will travel the 800 miles from Fermilab to surf through the Earth, right through the rock, because they pass through you and me and everything. We don't need a tunnel or anything. They're just going to travel. And it's 800 miles, and they're going to get generated at this time, and then they're going to be over here 0.4 milliseconds later. It's pretty fast. And they move through virtually all matter. They carry information. And the goal of the experiment, it will not be just to detect them. It will be to observe how they change as they travel. Neutrinos, oh yes, we have a question, yay! Wait, here comes the microphone.
Oh, okay. I was just wondering, you said they carry information with them. What information do they carry?
Well, they carry the information of themselves. So they have a mass, and there are 3 different kinds, and those are called flavors. And the really, really, really weird thing about neutrinos is that as they travel, that 800 miles, 0.4 milliseconds, they change flavors, which is incredibly unusual, that they would change their very nature. And that change is really, really subtle and really difficult to detect. But the physicists believe that the tiny difference in the way that they change as they travel may hold the key to understanding why matter exists at all. Why, after the Big Bang, did what should have been equal amounts of matter and antimatter not just completely annihilate everything, and that there should be nothingness? And yet there's somethingness, right? And physicists believe that understanding the neutrino and the characteristics and properties of the neutrino will help answer that question. And as a bonus, this is just extra, that once those detectors are actually operating, if there is a supernova, that supernova will produce immense numbers of neutrinos. And if we're observing those neutrinos, these extra neutrinos will be detected, and we can tell the astronomers, hey, you're gonna see a supernova over there really soon, so point your telescopes that way to see that actually happen. So it's an early warning system for supernovas.
Hey, Deb.
Yes.
Can you tell us when it will start? Like when
Dune?
And how long it will run?
Yes. Oh, you want? Yes. So we have been getting ready for the experiment, pre-excavation, excavation, installing, beginning to install the detectors for about 10 years now. and we'll probably be ready to start data collection in about 2030. And we believe that to gather the data to firmly answer the questions that are being asked, that experiment should run for about 30 years. So these are generational experiments. Again, the humility, the patience, the dedication to ask and answer those kinds of questions, really quite unprecedented. And it's fundamental science, right? It's not like, oh, hey, I learned this thing and now I'm going to build a widget, and that widget I'm going to sell and make a whole bunch of money. This is fundamental science. It's answering big questions that we don't yet know what we'll do with that information. Much like most of science started with fundamental questions and fundamental science that at some point may have applications that lead to your smartphone or your microwave or what have you. So we've talked a lot about physics, but I want to talk about the rest of the science just for a few minutes, because there's biology. The biologists are studying the extreme kinds of life that can live and survive and evolve and develop in crazy environments. No light, seemingly no food, low oxygen, high temperature, etc. Because it's looking at sort of what are the requirements for life to exist here or maybe anywhere. And then, whoops, it's going to go and then it's going to go back. And then geology, great geology happening. And probably one of the most exciting things is enhanced geothermal. So beginning to understand how we may be able to extract heat that's deep in the rock, and how that heat might be extracted as a renewable, low-carbon energy source. And so the science is beyond the physics for sure, and multidisciplinary. So when you see something like the deep underground neutrino experiment or the search for dark matter, it's easy to focus on those really big questions, but there's another set of questions that matter as well, and that is, what does it take day after day to work in an environment where you are working a mile underground? How do you do it safely? How do you do it responsibly? Because going a mile underground to do science doesn't just raise scientific challenges, it raises operational, environmental, safety, etc. challenges. Yes?
So I'd ask the question before you move on. So going back to that first experiment that you talked about with the dark matter.
Yes.
How was it detected that it was xenon that is the element that is going to interact with the dark matter?
Oh, you just brought out the chemist in me, like that's the best question. So xenon is a noble gas, and so it's not reactive, but it is a gas. And it's a heavy element. And when you condense a gas into liquid, you get the nucleus. It's a big fat nucleus. Basically what you're doing is really increasing the probability that if a dark matter particle happens to be zipping by, it's actually going to hit that target. Now, there's a lot more reasons why xenon, but a nice reason is it makes a good fat target.
Back a little bit.
Yes.
You're sending neutrinos from Chicago.
Yes.
But there's trillions and trillions of neutrinos.
Yes.
How do you know it's a Chicago neutrino?
How do you know that they're Chicago neutrinos?
Yes.
Because it's going to be a really intense beam of them. And it's going to be directed at exactly at the target. Now, you won't know that every interaction is coming from Chicago, but a whole lot of them are, and you will also know when that pulse is sent. Now, there will be other interactions in that giant cavern, in that giant tank, this time argon, but you're going to have the majority come when you have that huge beam of them. All right. Let's do this. So this is a video showing people moving from the surface, getting on the cage, and we're not going to watch a 12-minute ride underground, but moving people and stuff a mile underground. Doing this work safely and reliably is absolutely critical. You're working a mile underground. And so there is a safety culture that is who we are and what we do. And it is absolutely essential and critical. In addition, I mentioned water. Water infiltrates the underground all of the time. SURF has its very own wastewater treatment plant. So we're gathering or collecting the water that is infiltrating the underground. We are pumping it to the surface. We are taking it to our wastewater treatment plant. The wastewater treatment plant is treating that water, filtering it, cleaning it up, and then uses bioremediation. So it's using bacteria that eat the ammonia and metals that we don't want to have in the water, and it's also thermally treated before it goes back into the environment, back into Gold Run Creek. And so it is clean, and it is at a proper temperature. That system operates continuously. It is essential for what we do. It is not optional, and it's built into the work that we do. All right, so those are some big pieces of equipment, and those are a mile underground. And do you wonder how they got there? So those big pieces of equipment come to SURF. They are then disassembled. Most of them are not Lego-like, but we disassemble them. And then what you're seeing there is what is called a slung load. And so they hang those big pieces underneath the people conveyance. And they are lowered a mile underground and then reassembled. Our executive director, Mike Hadley, says that building Dune, the deep underground neutrino facility, is like building a ship in a bottle, except the neck of the bottle is a mile long. And that is exactly what we're doing here. Everything that we do, though, is about the people. So yeah, we have scientists from around the world, but we have engineers and technicians and educators and electricians and operations and safety folks, because the work is super complex. And it takes all of those people. Most of those people don't show up in the papers that are written, right, about the experiment. But they're absolutely critical for the work to get done. In addition, I want to mention the fact that SURF sees the work that we do as an opportunity to give back as well. And so our outreach team our education team, our communications team, our visitor center team work hard to share the story of surf and opportunities for learning with a broader audience. We have some of our outreach staff with us, some of whom spent time this week in classrooms. This past year, we worked with 20,000 students across the state of South Dakota and 400 teachers. So students come to surf, but we also go to them. And I think I'll leave it with this. As I come kind of to the end of what I wanted to talk about, I want to circle back to the idea of awe, looking up at the night sky and going underground. And one thing that has become really clear to me through this work is that uncertainty is not failure. In science, uncertainty is often the engine that leads to great questions, that keeps us asking better questions, building better experiments. Dark matter hasn't been found yet, but we know more than we did before, and we've shrunk that haystack. And none of the work moves quickly. 30 years that dune will likely operate. I've also come to believe that mystery is not something to be afraid of. Mystery can be an invitation. You know, it can be an invitation to pay attention, to stay curious, and to resist the temptation for easy answers. And good questions are gifts. Asking good questions are gifts because they provide opportunity for us to come together and think together and be in community together. And tonight is not about answering questions, but it's just about asking good questions and holding them well. And I see a hand, and I'll say this as well. I would take any additional questions at this time.
I'm wondering, you've talked about these neutrinos. Do they have a relationship, like you showed in your picture there, to the northern lights, the ionized particles that make the northern lights?
Yes.
What is that relationship, if you can?
It's a lot of the same kinds of particles that are in cosmic rays are also the particles that are creating the northern lights.
Oh,
yes.
Thank you.
Yes. Open it for, any questions?
This is not a scientific question.
Oh,
but
dear.
On a given day, how many employees are usually down into surf? And then also, you talked about the cages or the elevators. Mm-hmm. I heard there's no bathroom. So I was wondering, do the cages go in shifts so people can, because it takes a whole 12 minutes for it to go down, so do the elevators go in shifts throughout the day?
Okay, let's see. Surf employs about 225 full and part-time people. And on any given day, the number of people that are underground will vary. There is a maximum number that are allowed underground at any time because we need to be able to evacuate the underground within an hour if there were an emergency. So that actually plays into how many people can be underground at any one time. And then your other question was about, like, yes, the cage has times. If you miss your cage, you may not be going to work. And if you forget your lunchbox on the surface, you hopefully somebody's going to share. There are bathrooms. Oh, yes. And we're very excited to say that on the raw side, which is there are two sides, there are now flush toilets. Because porta potty and world-class science don't necessarily go well together. But yes, there are porta potties. Yes, there are flush toilets in some places. Yeah.
You talked about these two fans that help circulate the air.
Mm-hmm.
I'm just curious, I'm not the brightest guy around, but if you're a mile underground, how does all the oxygen get down there, and is Is that why you have to evacuate within an hour because it'll run out of oxygen, or?
Well, you don't want to be underground in a fire. So, I mean, like, that would be bad. But the fans are pulling air. So, you know those two ways that you get down? Those are downdrafts. And so it's actually windy. And you can, in a lot of places underground, you can actually feel the wind. So they work really hard with air doors and the fan system for that ventilation. And you also wear a device, or somebody in your group wears a device to make sure that you're not in a low oxygen area. But yeah. All right. What I'm going to do is I'm going to stop at this point because we have a couple of other folks that are going to push us to think. And I want to hear from them. That said, I will be here afterwards and happy to have additional conversations. Thank you all so very much.
So my quick transition from science to religion, when we were out at SURF, Deb handed out these boxes, and we were supposed to roll this marble around in the box, and then we had to write down what we thought were like in the box, like if there were places where it caught, or like what did it look like inside the box by moving that marble around. So we did that, then we got in different groups and we asked the same questions, and then I said, and a lot of us did, like, okay, so now what's the right answer? Like, we'd tried it, now give us the answer, because do you like to have an experiment and not know the answer? No, and Deb goes, I don't know. That wasn't the point, right? There's this sense of, like, she was helping us to see that there's things in science that aren't necessarily cut and dry, and this is exactly what it is, and here's the A plus B equals C, right? That there's this place of, like, wonder within science. And for a lot of us theologians, we said, that feels a lot like what? Religion. It's asking questions, it's wondering, it's maybe, when people ask me a question as a pastor, I want to have all the perfect answers, but guess what? I don't. And sometimes I learn new things or understand new things about who God is, and that seems very similar. And so for me, marrying these together seem very important and very sometimes I want the answers, but they're not always there, and that's the same in science and religion. And so now I'm going to turn it over to Richard and Steve, and I'm going to let them tell you a little bit about themselves and their background.
Hi, my name's Steve Matzner. I'm a biology professor at Augustana University.
And I'm Richard Swanson, now retired religion professor at Augustana.
So just a little bit about myself, and I might stand up. So I've been teaching biology at Augustana for 27 years. A lot of the time I teach evolution to first-year students, and so I've been thinking about how to broach the subject of evolution because students come with so many preconceptions about what it is. A lot of times they don't know how their faith views evolution, and they certainly don't know how they view evolution. And so I found that to teach evolution, I kind of need to talk about faith or religion a little bit to get those questions out of the way before I talk about the science. And so I've been thinking about science and faith and how to have discussions about that for a pretty long time. And I guess one thing I'll say, we'll take any questions at some point here, but trying to be respectful of other people's viewpoints. Some people do come from faith traditions where evolution, they've been told if you believe in evolution, you're going to hell. So these conversations can be very emotional and can be very troubling for some people. And so just trying to be as open and respectful of different viewpoints, and also realizing that it takes time for people to figure out what they really believe and to shift viewpoints. So I guess that's my little 2 cents today. I'm gonna let Richard introduce himself and his background a little bit.
As I said, I'm Richard Swanson. I have had the great privilege of having been the son of a scientist. My father was an ag teacher who was simply enamored. He was besotted with science. I remember we were walking outside and we were looking at the stars, and my father was telling me how far away the stars were, how impossibly far away, so far away that the light took years and years and thousands of years to reach us. And then he was telling me about spectrum analysis of that light. And he said, we find the same elements in those stars that we find here. He said to me, that means that you are made of the same stuff as the stars. And every time I remember that, the hair on the back of my neck stands up because of a word that Deb used, awe. My father looked at the world and was in awe of it. And that for him was deeply basic. That's simply who he was. He was also a man of steady and probing faith. I had the good fortune, therefore, to be raised with no notion that the awe in the face of the universe somehow excluded religion or vice versa. The two always simply sang to each other in my father's understanding and therefore in mine. So that when I first encountered the notion that somehow or other religion and science were opposed to each other, it was a surprisingly impossible idea to think about because they simply never had been. It's like asking how many bones are there in ice cream? It doesn't mean anything. The two simply always belong together. When we encounter students who find these basic responses to the world as somehow antithetical to each other, we end up having one of the most important tasks that a teacher ever has. It's really easy to scoff at people. That's the simplest thing in the world, and it's also stupid, and it's terrible teaching. But students have reasons for their rejection. Usually they've been taught that the two have nothing to do with each other. I'm interested in how things got the way they are. One of the reasons that that science and religion are presented as separate from each other has something to do, first of all, with the days back in the high Middle Ages when theology was called the queen of the sciences. Now, no one would call it that now. I'm guessing that that was never introduced in your education or in anyone else's. But what it meant was theology was human effort to put its arms around everything. And because theology is always about putting its arms around everything, it was rooted in the deep desire to simply understand fully and comprehensively. But a consequence of that was the ethical structure of the universe was understood to be just as real as the physical structure of the universe. And so the laws of ethics and the laws of gravity, in fact, embrace each other. Each one is as real as the other. This is a marvelous thing. But with the Enlightenment came a strong desire to think without having to ask a priest first, to understand without having to get the dogmatic right answer straight before you actually thought further than that. And as a result, those two ways of responding to the world, for some people, grew apart. What do you do when those ways grow apart? Well, short story. My father loved genetics. My father absolutely loved genetics. Some years ago, you maybe have heard about the Nobel Science Conference that they hold at Gustavus Adolphus College. It is a marvelous thing. They bring in scientists of worldwide reputation, and you get to talk with them. You get to go to lunch with them. It is an astonishing thing. After they had decoded the human genome, they brought in all the scientists who were in the front edge of that research, all of them. My father had been reading about these people for years, and they were all on the stage, and they talked about what they had just done and what it meant. And it was such fun because their sense of awe was just like my dad's sense of awe. And so we'd go to sessions, and then we'd listen, and we'd go back to the hotel and argue all night long. It was one of the most fun times I've ever had. The last day of the conference, all of the guys were up front together, just answering questions. They got great questions. What could we do? And they talked about how we can eliminate diseases, how we can correct genetic errors in beings. And it was just an astonishing thing, all the things they could imagine happening. Toward the end of the evening, a young woman came to the mic and said, "Thank you for what you have done. Thank you for your awe. And thank you for what you have given us as a glimpse of the future. I have one question. You have told us what we can do. Is there any limit on what we should do?" It was an astonishing moment because these geneticists, these scientists, these articulate human beings, highly educated, suddenly commenced looking at their shoelaces for minutes. Shoelaces, I never knew they were that interesting. And they're staring at their shoelaces. And finally, down at the end, there was a geneticist who was also an Anglican priest. And he said, "Well, I can see that no one else is going to say a word. So I think I can perhaps speak for all of us when I say, there is not one of us that is hoping to have some priest mucking about in his laboratory." Do you hear the implications of what he just said? There are no limits. If there are no limits, how do we make ethical choices? If science can and therefore should, that raises questions that as human beings, we have to ask with great care. When we're talking about neutrinos, not a problem. When we're talking about editing children so that rich people can have athletes and musicians and the rest of us are stuck with whoever comes out, as it were, there's someone who's got to ask a question about what ought and ought not be done. How do you ask that question? That will always be a theological question somehow.
And in the current environment where so many see science and religion as being separate, then where does that opportunity even come? Like they're separate from each other. I'm gonna actually just show a couple of slides. This one is one that I introduce students to, and it just gets them thinking about how do they view the relationship between science and religion. And there's 3 or 4 or 5 choices. I kind of narrowed it down to 3. But the 3 kind of main ones are that you can view that the relationship between science and religion is inherently in conflict. And if you're atheist, you would be in that viewpoint, you would have that viewpoint. But if you're a young earth creationist, you would also have that viewpoint, that science and religion are in conflict with each other. They tell us different things that conflict. There's a lot of people that like the second model, the independence model, that's kind of like, religion answers questions of faith and meaning. Science answers questions of how the world works, and they're just independent from each other. I find that one unsatisfying for me personally. For those of us that come from a faith tradition where we believe that God created the earth through what scientists study as natural laws, that would be under the integration model. And for those students that I work with who come in concerned about the relationship between science and religion, and they realize that, it's okay for me to believe that God created everything, that the science I'm studying is consistent with what God created, you can almost see the relief in them in terms of, it does not have to be a problem for me. And so kind of my take-home message almost always for students is it doesn't have to be a problem. The science and religion can be compatible. If you think about these models, and maybe I'll just challenge you all to think about, which of those models fits you the best. And I've got a question for you to talk about with your neighbor. So, how do you think the science being done at SURF would be viewed by people under the conflict model versus the integration model? And if you want to do the independence model, you can, but for time, I thought I'd limit it to the two that are perhaps the most different. So, this is where I want to hear some talking. All right, I gave you about a minute. Interestingly enough, when I'm in front of a class, I can almost always tell when they stopped talking about the question I asked and they're starting to talk about something else. The sound changes in an inexplicable way. Anybody willing to share a thought? Yeah, in the back.
I think that the conflict model would say that SURF shouldn't even happen. And so that it wouldn't even be negotiable to do that kind of research, that it was against God. I think the integration model, I think what's so wonderful about science is that not only does it reveal our own character, but actually through science you can reveal the deeper character of God.
Very well said. Anybody else have any thoughts they want to share?
One of the things that's interesting about an integration approach to the SURF project is it supposes that, in fact, the partners to the conversation would choose to integrate. In fact, I am not a physicist. I was raised by a scientist, but I'm not a physicist. I know as much about neutrinos as the average ignorant guy. And some of the scientists I know are not people of faith. So for them, integration isn't an issue at all, as long as no priest mucks about in their experiment.
So I do think it's valuable to have these conversations and to think about it. And I'll present some polling data that exhibits why I think it's important to think about this. So if this is a Pew Research Center poll, and they ask the questions, how do Americans view the relationship between science and religion? Are science and religion in conflict? And 50% of Americans say yes. 35% of highly religious Americans say yes, but 73% of kind of less religious Americans say yes. And 68% of religiously unaffiliated Americans say yes. I remember when you saw this, you were very fascinated by this data.
Oh, yes. Well, it's fascinating. One of the things you need to do, well, who was it that said, there are three things to look out for. There's lies, there's damn lies, and there's statistics. You got to disaggregate the groups and find out who's actually in them. So highly religious means what? Self-identified as highly religious, externally identified as highly religious. I'm a religion prof, but some of my students are sure I'm not religious at all. They're quite wrong, but who gets to decide what's highly religious? Less religious, there's a lot of people who are less religious, but the 68% is the one that interests me. Religiously unaffiliated people say, Americans, I can't talk English. Religiously unaffiliated people say the two are in conflict. Why? For the same reason that highly religious people say that? These numbers are hard to chew because it isn't quite clear what they mean, but my guess is that religiously unaffiliated people don't care if it's integrated or in conflict. They just look at the fundamentalists amongst us and say, they must be in conflict because all of those people hate what I do. It's complicated.
Yeah, I think people who are not particularly religious have the impression that science and religion are in conflict.
Because they've run into religious people that can't think their way out of a scientific paper bag.
All right, so that's from Pew Trust. I think this one's also from the Pew Trust. How do different religious groups view science? And the question was interesting. It's, does science do more good than harm? Less than half of Christians Americans say yes. So that means more than half apparently think that it does more harm than good, right? 75% of Jewish Americans say yes, 56% of Muslims, 62% of Buddhists, 71% of Hindu, 63% of unaffiliated Americans. And so there's definitely something going on with Christians in particular that's picked up on this.
Yeah. Again, who exactly are the people in these groups? One of the things that matters is noticing the high score given to the good of science by the Jewish community. If you have Jewish friends, you know that higher education is highly valued in that community. And therefore, there is a natural lean toward the integration of scientific ways of knowing things, intellectual ways of knowing things, and the existence of a person of faith. If you know anything about the history of Islam, you know that Western philosophy was preserved for Christian Europe by Muslims, because there is a deep commitment to intellectual endeavor in that community. If you know anything about the history of American Christianity, You know that the growth of fundamentalism started as a nativist movement. It is rooted in movements in the late 19th and early 20th century that were afraid of the disjointedness that followed the Civil War and the First World War. The world was up for grabs. Everything had been knocked cockeyed. And in the face of that, people respond in predictable ways, one of which is the fear of anything different. Well, at the same time as all this was going on, refugees from the wars of democracy in Europe were entering the United States as refugees, as immigrants. And they brought with them, typically, a rationalist mindset. And they were done with fighting against religionists who had, in fact, persecuted them. In the face of this wave of godless immigrants, the fundamentalist movement rose up and said, you got to be a real American, and to be a real American, you got to be a real Christian, and to be a real Christian, you have to be anti-intellectual. Now, it's more complicated than that, you know that. But part of why the American Christian numbers come out the way they do is the holdover from nativist fears, the fear of anyone who's different, and especially rationalists who are different.
So every time he and I sit down, I just enjoy the conversations that we have. Yes. There's been several times when I wish we had taped them when we were in my office talking, and I always learn something new. I'm going to show you 2 more slides, I think. So if you poll Americans about this particular view, 40% of US adults ascribe to what is referred to as a strictly creationist view of human origins. That is, that God created the earth and everything here and us in less than 10,000 years. There was a bishop in the, 11th or usher in the, 11th or 12th century who figured out, that it was about 6,000 years ago. That number has kind of stuck, but somewhere less than 10,000 years. Now, the implications of this is that from biology, from physics, from astronomy, chemistry, all of those sciences know that the Earth is much older than that. And so this viewpoint conflicts with all known science. And so if you're ascribing to this viewpoint, you have to reject science. And this is prevalent in America. And we should talk more about it because this has implications for science, for education, for politics, for religion, for basically everything. So I think I got one more question. So how do you think the advancement of science is changing people's faith in America? And I'll let you discuss amongst yourselves. And then I think we'll open it up for questions. All right, I think I've given you about a minute. The hardest thing as an instructor is giving people a minute. It really is difficult. I really love the little clock up there. It's very handy. Anybody have anything they want to share of their discussion? Yeah.
Well, we're thinking that the science about cloning is really kind of scary. So what is the line? I think that for us, this whole row, that was our concern.
So there was cloning done in China here a few years ago and somewhat of a backlash against it. I think a lot of places have, if not formal rules, at least informal rules for now. But there's lots of places in the world where you can do whatever science you want to. So it may happen again that there are people being cloned. I think part of the problem and why I want to see more conversations about science and religion is because that's a conversation we should be having much more publicly than we're having. And because of this rift between science and religion, we're not having the right conversations.
One of the places that I have gone to think about exactly that issue is to the work of Dietrich Bonhoeffer. Bonhoeffer is worth reading. Bring a machete, some of it's a little thick and you'll have to hack your way through. It's worth it. In his ethics, he roots all ethics in responsibility, which means we live as human beings who have to look each other in the eye and be answerable to each other. Now that is the first place he roots ethics. We have to look each other in the eye and be answerable. And so if the young woman stands up and says, "Is there anything you ought not do?" Someone was responsible to look her in the eye and say, "No," or "Yes, and here's why." But Bonhoeffer goes farther. He says we are also answerable to things. And what he means is, in the world as a creation, as he understands it, things have a proper use. And there are uses to which you can put things that are improper. Now, I love that. And then the rat went and died. No one knows what he meant. If he had lived out longer than the war, we could have asked him, what in the world do you mean things have a proper use? How would you know the proper use? He died, we don't know. But notice what he's doing. He is saying that material is not just material. Material is also a creation of God, and therefore has built into it improper uses and proper uses. That's worth thinking about, even if we don't know for sure what it means.
Because you used the word ethics, and I was wondering if part of the conflict, when you use the word religion, that turns buttons on or off for people. The word ethics tends not to have the same visceral reaction. So the question of what ethically should you or shouldn't you do, and you really answered my question.
And you're pushing on something that matters enormously. It's why the first thing I talked about was the queen of the sciences putting its arms around everything. The effort to embrace, to comprehend everything, means that we cannot write off questions of responsibility. The fact that I can do something to you does not mean that I should. But how in the world do you root that in the patterns that give your life meaning, which is part of what religion as a whole is? Yeah, good question.
Richard mentioned the story about how the the researchers didn't want a priest mucking about in their laboratory, really, looking over their shoulder and telling them what they can and cannot do. But at the same time, like AAAS funded this project because scientists really do want public input into what are their limits. They don't want to be the only ones making that decision. And they're seeing a real lack of those discussions happening in the American public to give them the guardrails that they want. And so promoting these discussions and coming up with some guardrails for scientists, that's something I think most of the scientists would actually be very happy about.
This isn't a question, but a couple of comments that we talked about with this question. And one was, we kind of switched it around and said, sometimes faith or religion can hinder the advancement of science. And then as well, maybe science can actually help people with their faith, because there's a lot of things that scientists do, from subatomic particles to more biology and everything else, that can bring awe back to people of faith.
Yeah, I would say that a lot of the scientists that I know who are faithful people are very much in awe of God's creation and just feel very blessed to be able to study God's creation. I think I mentioned this, I don't know where I mentioned it, but Deb reminded me that I said something like this at one point, that depending on your view of this relationship between science and religion and how you view God, if you are of a faith mindset that science is in conflict with God, then as science increases, your God shrinks. The space for God becomes less. If you are of the mindset that all of this creation was created by God and scientists are basically figuring out God's code and seeing how amazing and how awe-inspiring this universe is, and then as science advances, our understanding of God gets bigger. God gets bigger. And that's people. My father's 90 years old. His biggest concern is that this country is, becoming less Christian. And I think, if we want young people to embrace faith, it's got to be a faith that allows them to see the wonder of God and not the conflict and not, this fight for a God that's against science. That's never going to sell to young people. But as science advances and we see how big the universe is, the wonder of creation is enhanced, for me anyway.
Yeah. Just this last week, I finished a book from a few years ago that had been recommended to me by so many of my students, I finally had to read it. The book is titled "The Spirit Catches You and You Fall Down." Has anyone read that? Yes, some of us have. I have forgot the author's name, it fell out of my head, but "The Spirit Catches You and You Fall Down." It is a fascinating story of a young girl born, a young Hmong girl, born with epilepsy, born to a family that spoke and still speaks no English, born to a family of Hmong culture, which is powerfully anti-authoritarian and powerfully rooted in its understanding of the world, which precludes medicine as Western physicians understand medicine. And the book explores the consternation, that's not strong enough a word, of the physicians who are trying to treat this girl and being treated as the enemy because they are taking blood, and human bodies have only so much blood, according to Hmong understanding of physiology, and if you take it, they will die. Plus, in Hmong culture, epilepsy is a sign of divine privilege. Should you treat the seizures and thus take away the presence of the divine in the world? The book is fascinating and frustrating, but it is fascinating in that the author finally takes seriously both the religion, both religions that are operating, because in both cases, the physicians and the family have an absolute commitment to the way they understand the world to hold together, and that is a religious structure. An absolute commitment to the way you understand the world holding together is that's a theological question. What do you do when you stand in the middle of that conflict? It's not simple, and the author has no answers that I think are convincing, but I found it fascinating to read, and it puts an edge on what we're trying to think about tonight. It's pretty easy when your father's a scientist and a Christian all at the same time, and it works nicely together because rationalism and Christianity have been asking each other to dance for 4 centuries now. What do you do when you have religion that simply looks at the world entirely differently? How does that change the questions we're trying to ask and think about? Oy, that book kept me awake.
Parting words?
Maybe from where I sit, only this. Your presence here is a sign of how important it is that we look for ways to talk, to have complicated conversations about this. Simple conversations where we all just pat each other in the back and sing Kumbaya and all go home. That's easy. We're here for something better than that, and that's why we have enjoyed talking to each other all these years, because there's neither one of us. I don't know a scientist that doesn't love complexity, and if you don't love complexity and you're a theologian, sell shoes.
Yeah, I hope everybody out here is not struggling with how to integrate your science and your faith, because we live in a technological world, and it's amazing all of the science that's out there. And when I see new discoveries, I'm sometimes just blown away. It's like, oh my goodness, that's just so amazing, and that helps feed my faith, and I find that very, very good, very amazing, really. Yeah. So. Thanks all for coming.
What do you suggest, or what recommendations do you have for us in our conversations going forward with our friends and our neighbors and the people that we run across table?
Do you want to repeat that?
So the question was, what recommendations do we have for having conversations with your friends and family about this subject? I will say that I come from a mixed family. Some of my family is very liberal in their religious views, and I have also some very conservative family members. And to be honest, we often avoid the conversations that would not be fruitful. My father's 90 years old. We actually enjoy arguing with each other, but we're not going to change each other's views at this point. And I would say I have a very good relationship with my 90-year-old father, and I'm very grateful for that, because I lost my mother a few years ago. And so I don't want I don't want to try to convert him to my viewpoints at this point. I just want to love him and spend as much time, with having a good relationship with him at this point. If you do talk with people, I think a couple of things that you need to be mindful of. One is the more you push, the more they're going to become defensive. So try to avoid things that are going to make people defensive. That's usually not going to work. I think, and I'm getting to parts where maybe your views or your advice would be better than mine, but be respectful, listen. If neither side is listening, you're not going to have a conversation. If you end up in a conversation with somebody who's obviously not going to listen to you, it's not worthwhile. But if you can get into a moment where both sides are listening to each other, who knows? And I think the other thing that has really been resonating with me lately is I'm not very good at prayer. I never have been the praying person, but sometimes that's really all you're left with is to pray. Pray that your friends, your family get to a better place, because for folks who have this very fundamentalist viewpoint and anti-science viewpoint, it's a hard world to live in. I mean, we live in a technological world. They're getting bombarded by science all the time that's threatening to their faith system. That makes their faith a very fragile faith. That's why they're so defensive, because their faith is very fragile. You cannot have a robust faith that can't handle science. I mean, you can't. And so, pray for people whose faith is not strong. They think it's strong, perhaps, but if science is a threat to your faith is fragile.
And only a small thing. I like that very well. I think that's practical and productive. My father was a very fine teacher, and one of the things he taught me is most of teaching is listening. And that has shaped the way I've tried to learn how to teach. I've tried as hard as I can. And maybe, again, the complexity of theology is a good place to learn that. Theology starts with the word God, which, if you paid attention in the 5th grade, is a proper noun. As a noun, it's a person, place, or thing. Only God is invisible and inaudible. That intangible, that is the strangest concrete noun you'll ever run into. But that means that if you're going to have a theological conversation, one of the first things I have to do is hear what you just did when you said the word God. Because book, foot, those are easy. God? Until I know what you mean by that word, until I've listened to you long enough to know what is at stake, the conversation has no future. Now, there are conversations that never have a future. That's just true. Life is hard. But in fact, sometimes sitting and listening to what it is they mean when they say God, when they say creation, and it takes sometimes forever. You sometimes discover that you actually understand each other, at least potentially. And my favorite moment, one of our students who was powerfully committed to believe that coming to a place like Augustana, the religion professors existed to take their faith away, and the science professors were worse. Partway through the intro course, she came up after class one day. I'm very proud of this. I don't like telling proud stories, but I like this one. She came up after class one day and she said, "I'm supposed to hate you." Why don't I? Well, I blame it on my old man. He taught me to listen first.
Yeah, I would have to say that teaching, you have to listen as well. And for those students who've struggled with this relationship between science and faith, probably one of the more impactful things that I feel like I've done as a teacher has been for those students who just feel this relief. You can see it in their eyes of, oh, this isn't going to be a problem for me. I can study the science that I love and still have my faith, and it's all okay. That is deeply rewarding when that happens. You guys have been wonderful.
A big thank you for coming, and if we want to give them all a round of applause. I believe they will be around for questions, question mark? Deb will. You guys will stick around for questions, and just thanks for coming. Have a good night.